Okay, today we're going to do day 2 in the Trig unit, Trig word problems. Things you're going to need for today are a note sheet, a graphing calculator, and then something to write with, preferably a pencil, but a pen will work. So a bit of quick review. We want to know what is a reference angle, usually represented by theta, and when you have a reference angle in a triangle, you have the sides in reference to it. You always have the hypotenuse across from the right angle. Across from your reference angle, you will have the opposite side, and the remaining side is the adjacent. One thing to remember, though, is that there are two acute angles in a right triangle. So, you will have two reference angles. Both will have the same hypotenuse. However, they will have different opposite sides and different adjacent sides. They will be flipped. So in this problem, you're going to use your knowledge of trigonometric ratios to find the measure of x to the nearest degree. You're also going to use your knowledge of triangles to find the measure of y. So here we have two reference angles that are given to us. We're going to start by finding the measure of x. And once we know that we've labeled our reference angle x, next we're going to label our triangle. In other words, we're going to label the sides of the triangle, the hypotenuse, which is across from the right angle, the opposite side, which is across from the reference angle, and the remaining side, which is the adjacent. We noticed that we have the opposite and we have the hypotenuse in terms of sides given. We remember back that the trigonometric ratio that involves the opposite and the hypotenuse is the sine of theta, in other words, the sine of the reference angle. Since our reference angle has a value of x, we say that sine of x is equal to the opposite, 8, over the hypotenuse, 15. Now remember, we're looking for the measure of x, so this means we need to get x alone. How do we do this? Well, simply put, we take the inverse sine of both sides. When we do that, we're left with x alone on the left, and we're left with the inverse sine of the ratio 8 over 15. To input this into your calculator, first make sure that you are in degree mode. We covered this in day 1. If you do not remember, please go back to the day 1 video or follow the instructions that I just pressed on the calculator. Next, press second, sine, that will give you your inverse sine, and type in 8 divided by 15. Press enter and this will give you a decimal answer. By rounding to the nearest whole number, we find that x is about equal to 32 degrees. So now, we want to use our knowledge of triangles to figure out the measure of y. Well, we could use trigonometry to figure it out. However, that would be a long and involved process. What we can do is dig back to geometry and remember that the triangle angles add up to 180 degrees. What this means is that when you add all of the angles together, they should add up to 180 degrees in a triangle. So, to figure out what the value of y is, we simply take 180 degrees and subtract out the two angles that are within the triangle. In this case, the 90-degree right angle and the angle we just found, 32. We plug this into the calculator. You should come out to a value of y equal to 58. In our second example, we're using trigonometric ratios to solve for the missing side to the nearest tenth of a unit. Now, here we're given a reference angle and one side. We're trying to find the other side. We can still use our trigonometric ratios by utilizing our knowledge of reference angles. So, first step, label your sides: hypotenuse, opposite, and adjacent. We know that we have the hypotenuse and we want to find the adjacent. So the trig ratio we want to use is going to have both of those sides utilized. This ratio is obviously the cosine, or cosine of theta, equal to adjacent over hypotenuse. So we know that our theta is 32 degrees, so we say the cosine of 32 is equal to our adjacent side, the unknown x, over our hypotenuse, 6. Now to solve for x, all we have to do is multiply 6 to both sides. The 6 on the right cancels out, and we are left with, on the left side, 6 times the cosine of 32. You plug this into your calculator, and you get a value of about equal to 5.1 when you round to the nearest tenth. Okay, so now we're going to talk about the angle of depression and the angle of elevation. Both of these angles are created in relation to a straight line of sight. In other words, I'm going to start by looking straight out. The angle of depression is created if I look out and then I look at something that is below me. In other words, I am going to look down. A good way to remember this is depression means you're getting down. So the angle of depression is created when I look straight and then I look down. Similarly, the angle of elevation is created when I look straight out and then I look at something that is above me. Maybe it's a mountaintop, maybe it's a plain, maybe it's the top of the barn. Either way, the angle of elevation, I'm looking at something that's at a higher elevation. In other words, the angle of elevation is created when I look up from that straight line of view. A quick and common mistake that I want to cover is usually made when in reference to the angle of depression. You look straight out and then you look down, and the angle that is created is the angle of depression. However, many people mistake the angle of depression as being the bottom angle that is created, not the top. Your angle of depression is this top angle, the angle created when you look straight out and then look down, not the angle that when you're looking straight down and then decide to look up a little bit. So let's use these two in a couple of examples, shall we? In example 3, we're going to find the height of the building given an angle of elevation from the tip of its 122-foot shadow to the top of the building is 35 degrees. Note that we're using angle of elevation, so your angle should be looking up from a straight line of sight. Now, since we don't have a picture, in all of these word problems, I suggest you draw a picture. It helps you to organize your information, it helps you to better visualize the problem, and it's just plain fun. In this case, we're going to round all of the answers to the nearest whole number, and then continue on with our drawing. So, I'm going to start with drawing my building. Here it is. Nice little tall building with a relatively straight side. Let's pretend it's straight. Let's have a little window here, maybe another bigger window here. Hi. Happy little man inside. Hello, little man. Hi, everybody. And, of course, there's a shadow in the problem, so let's draw a 122-foot shadow. Now, let's assume that the ground is flat and straight, and it comes from the bottom of the building, so we're going to keep that shadow nice and straight. We're trying to find the height of the building. We're going to assume that the building is straight up and down, which means that the shadow and the building form a right angle. Well, it makes our life a little bit easier because we've been learning about right triangle trigonometry. Yay! So, we're going to draw that straight line from the tip of the building to the tip of the shadow, and we know that that angle of elevation created is 35 degrees. We're going to label the length of the shadow 122, and we know it's 122 feet, and we know that the height of the building is going to be some unknown number. I'm going to call it the variable x. We used our reference angle of 35 degrees, and we label our sides hypotenuse, opposite, and adjacent. We notice that we have the unknown side, x, is our opposite, and 122 feet is our adjacent, so we are going to use the tangent ratio, opposite over adjacent. The tangent of theta, in other words 35 degrees in this case, is equal to the opposite, x, over the adjacent 122. If you plug this into your, if you do the algebra, you get x alone. You're going to multiply 122 to both sides, which will leave you with 122 times the tangent of the tangent of 35 equal to x. You plug that into your calculator, and you should come out to a value of 85 feet for x. In example 4, we're trying to find an angle of depression from a parachutist to the base of a tree if he is 360 meters from the tree and 500 meters above the ground. Once again, draw a picture. So, here's my little man. Hi, little man. Hi, everybody. Well, he's a parachutist, so he's probably going to have a parachute. Yeah, that would be helpful. I wouldn't want to fall too far. Well, there's his little parachute. And, of course, in this problem we also have a happy little tree, as Bob Ross would tell us. I like drawing happy little trees, don't you? Don't forget that every happy little tree needs its stump. There it is. Now, let's also remember that we need to have the ground there. From the parachutist to the ground, it's going to be about, or as the problem tells us, 500 meters. So we're going to label that vertical line 500. We're also going to assume that the ground is flat and straight, and that the distance from the parachutist, if he were on the ground, to the base of the tree is 360 meters. Well, we're going to draw a line from the parachutist down to the tree. Now remember, we are given, or we want to find the angle of depression. If we go back a couple of slides, we remember that the angle of depression is created when you look straight out and then you look down. Not this other angle that's at the top of the triangle. What you should notice is that that straight line of sight is parallel with the ground, which means that the opposite interior angles which are created are congruent. So now we have theta, which is our angle of depression, is equal to this angle of elevation from the tree to the parachutist. Now I can label my sides opposite, hypotenuse, and adjacent. And I notice that I once again have a tangent function because I have the opposite side and the adjacent side. The tangent of that theta is going to be equal to 500, the opposite, over 360, the adjacent. I want to get theta alone, so once again I have to take the inverse tangent of both sides. This will give me theta on the left and the inverse of tangent of the ratio 500 divided by 360. I plug that into the calculator as you see on the right, and I get a value of theta equal to about 54 degrees. So, now that we've gone through this, here are the things you should be able to do. You should be able to identify and calculate the angle of elevation, identify and calculate the angle of depression, and know that these two are equivalent to each other. You should also be able to better solve word problems that involve basic trig ratios. Once again, this is Mr. Mackmin signing off, and I hope you enjoyed.